Today we shall continue with our episode on statistics for beginners. In our last video, we are able to talk about... Hello viewers, welcome to Ajadima's class. If this is the first time of watching our videos, please don't forget to subscribe, like, comment, and also share our videos on various platforms. Now, the first slide there, we'll be talking about the use of statistics and in regards to the central tendency, which includes the mean, the median, and the mode. And the formula for calculating Hello viewers, welcome to Ajadima's class. Today we shall continue with our series on statistics for beginners. So today we are going to be working on the mean and the median of grouped data. In our last video, we've been able to talk about mean and median of ungrouped data. So today we are moving straight to the group data. Now, looking at the question given to us here, we have these observations being grouped as shown here, and we have the frequency for each of it. Now, what we are expected to do is to calculate the mean, and don't forget from the definition of the mean that calculating the mean, we have that the mean is the formula for calculating the mean. We have it to be summation of x over summation f. This means that the summation of that is the plural of the frequency and the midpoint x, so which is what, fx. So we are going to get the summation and divided by the summation of this frequency. Now the first thing we are going to do is to calculate the summation of our frequency, and from here we know that our summation of our frequency is addition of everything. We have 3 plus 5 plus 6 plus 7 plus 9 plus 8 and 7. This is going to give us 38. That is the summation of our frequency. Now calculating our midpoint, because the midpoint is going to stand for our score. So calculating the midpoint between 40 and 49, just on a rough sketch, if you have 40 plus 49 over 2, and that's going to give us what? 89 over 2, and that's going to give us 44.5. So the midpoint of this is going to be 44.5. Calculating the midpoint for 50 to 59 is going to give us what? 54.5. This is easy to know, just add 10 to it since it is at equal interval. And this is going to give us 74.5. This is going to give us 84.5. And this is going to give us 94.5. So that is our midpoint. Now the next thing for us to do is to calculate our fx. That is the product of our frequency and the midpoint x. So 3 times 44.5 is going to give us, you can use your calculator for confirmation of this. This is going to give us 133.5. And 5 times 54.5 is going to give us 272.5. 6 times 64.5 is going to give us 387. 9 times 74.5 is going to give us 670.5. And 8 times 84.5 is going to give us 676. And lastly, 7 times 94.5 is going to give us 665. Okay? So, adding this together, the summation of our fx, this plus this, plus this, plus this, in total is going to give us 2,804.5. So this is our fx. So this is going to stand for our what? Summation fx. So calculating the mean here, we have that our summation fx, which is 2,804.5 divided by our summation f, which is 38. So this is going to give us 73.8. This is our mean. So this is the average for these data sets. So you can see that the method of group data is quite different from the method of ungroup data, being that here we need to calculate our midpoint because we need to know the average observation for this range of values. So this is mean. Now we are going to move straight to median of group data. And for calculating the median of group data, it has a formula, and the formula is easy to know. Yes, it is very easy to know. And for that, let me change my pen here. Yeah, let me change to red. So for our median, we are going to make use of this formula. Let me make it thick. Yeah. So we are using this LB subscript B plus N over 2 minus cumulative frequency before the median class times the class width all over the frequency of the median class. Now I'm going to say the meaning of all this. Here we have that our LB okay. So here we have that our LB, L subscript B, is the lower limit of the median class. Is the lower limit of the median class. And our N is the number of observation. Okay, we have that as our number of observation. We have our CFB to be the cumulative frequency before our median class. Okay, so there is the cumulative frequency before the median class. Sorry for using abbreviation. And we have our F subscript M, which is the frequency of the median class. So it's the frequency of our median class. And lastly, we have C, which is the class width, or let me say class size. Yeah, let's call this class size. Yeah, looking at this from here, we know that our lower limit, the first thing for us to determine is to determine our median class. And for you to determine your median class, in our last video, you can check. We've talked about how to determine median, okay, of ungroup data. Now, the summation F we have here is 38. So when you divide 38 over 2, it's going to give us 19, right? So let's calculate our cumulative frequency, and let's see first. So our cumulative frequency means addition of the subsequent frequencies. And here we have 3, starting with 3. Sorry. And next we have 3 plus 5, right? We have 3 plus the next value, which is 5. So that's going to give us what? Let me put it this way, that we have we have 3 plus 5, which is going to give us 8. And next one, we have the previous value, which is 8 plus 6, right? Sorry. And which is going to give us 14. So subsequently like that, 14 plus 9 is going to give us 23. 23 plus the next value, which is 8. Okay? Next frequency value, which is going to give us 31. And to the last value, which is 7, is going to give us 38. So this is going to give us 38. Now let's check. Since our summation F is 38. Okay, so our median class is going to be over 2, which is 19th value. So where does our 19th value fall? So we can see that it falls on this region. Yes, it falls on this region. So this is going to be our what? Our median class. Let me change the pen so we can see what we mean by the median class. So our median class is going to be this. So which is this? Straight down like this. So it's 70 to 79. So looking at this now, what is going to be our lower limit? So our lower limit is 70, while upper limit is 79. So our lower limit is 70, right? And our number of observation from 40 to 49. Students often make mistake here whereby saying that 40 to 49 is 9. No. So 40 to 49 is 10. We have 10 digits. Okay, when you count from 40 to 49. So here we can say that our n is 10. And the cumulative frequency before the median class. Since this is our median class, so the cumulative frequency before it is what? 14. Okay, that is our cumulative frequency before it. We have it to be what? 14. And lastly, we have our frequency. Our frequency of the median class. So the frequency, since this is the median class, the frequency of the median class is 9. Okay, so the frequency of the median class is 9, while our class size is 10. Oh, sorry, our number of observation can be 10. That is a mistake from my part. It's 38. Okay, our number of observation is the same thing as summation F. Okay, now doing this, we are going to make use of these values in computing our median. So coming down here, we have that our median will now be equal our lower limit, which is 70. We can decide to use boundary if you like instead of using limit. Okay, in bracket n over 2, our n, which is the number of observation, which is 38 over 2, minus the cumulative frequency before the median class, which is 14, all over, okay, we have this closed, times our class limit, which is 10. Everything over frequency of the median class, which is found to be 9. So going forward, we have 70 plus 38 divided by 2 is going to give us 19 minus 14, everything over 9 multiplied by 10. So here we have 70 plus 19 minus 14 is going to give us 5 over 9 multiplied by 10. So we have 70. You have 70 plus 5 over 9, or 5, let's multiply 5 by 10, and here we are going to have 50 over 9, okay, So going forward, we have 50 over 9. You can solve that using your calculator. So we are going to have 70 plus 50 over 9, because I am doing this without using calculator. We know that 50 over 10 is 5, right? So let's do that somewhere here. We have 50 over 9. 9 in 50, 9 times 5 is 45, right? So you have that as 5 point, remainder 5. So you can have that as 5.5. Okay? So because 9 in 50 is 45, remainder 5, add 0 to it, 50, so you can have 5.5. So here you have 5.5. And finally, our answer is going to be 75.5. So this is our final answer. One thing you will observe with the median is that the value you are going to get here as the median value must fall within this range from 70 to 75. If it falls outside this range, it shows that what? It shows that your answer is wrong. So you can see that the median class is somehow greater than the midpoint, which is 74.5. So kindly subscribe to our YouTube channel so that you can be notified of our subsequent videos on this series, and we hope to upload more videos. In our next video, we'll be uploading videos on how to do mode of group data and also of ungrouped data, and also try to help us share and like this video, comment. Thank you very much. See you next week. Hello viewers, welcome to Ajadu Math class. Today we shall continue with our statistics for beginners. This is our 4th episode on this series. Today we are going to start with the mode of group data, and in our previous videos we've been able to look at the mode for the mean, and we are able to look at the mean and the median of group data. So today we shall move straight to the mode of group data, and the formula for our mode of group data, we have that mode equals to the lower boundary, okay, LB plus F1 over F1 plus F2 multiplied by C. So we can possibly easily put this in a bracket for easy computation. So where our F1 is the same thing as the frequency of the median modal class minus the frequency before it. So looking at this now, this is our frequency of the modal minus the frequency before, and also our F2 is the same thing as the frequency of the modal class minus the frequency after it. And here our C is the class width. That is, you can call it the class interval also. That means the difference between the lower and the upper. And LB is the lower boundary. So these are the parameters that we have. Now we are going to use this to compute the information given to us there. Now for us to do this, now we are making use of the same formula here. We have that our mode equals LB subscript B plus F1 over F1 plus F2 multiplied by C. So with this, our lower boundary, the first thing we are going to look at is to determine our modal class. And our modal class is where you see the highest frequency, and this is our highest frequency. So this is where our modal class is, which is 25. The highest frequency is 25. So this is our modal class, that is 6 to 10 and 25. So this is what we are going to put into consideration. And for us to determine our lower boundary, we know that our lower limit here is 6. Okay, so you are going to subtract 0.5 from this lower limit 6. So our lower boundary is going to give us 5.5. In my previous video for the median, I decided to use the lower limit directly because you can also do that. But in this case, I'm going to use the lower boundary by subtracting 0.5 from the lower limit plus F1. Our F1, don't forget, is the frequency of the modal class minus the frequency before it. And the frequency of our modal class here is 25. So let me put that in bracket for easy computation. Minus the frequency before it, which is what? 20. That is my F1. Everything over F2, which is the frequency of the modal minus the frequency after it. And the frequency of the modal class is 25. The frequency after it is 23. That is my F2. My F1, I'm going to repeat this, which is 25 minus 20. Multiplied by my class width, which is 5, from 1 to 5. So which is 5. Now simplifying this further, I'm going to have 5.5 plus 25 minus 20 is going to give me 5 over 25 minus 23 is going to give me 2 plus 5 multiplied by 5. And with this, I'm going to have, my mode is going to be 5.5 plus 5 over 7 multiplied by 5. So with this, I'm going to have 5.5 plus, 5 times 5 is going to be 25. 25 over 7 is going to give me 3.57. We can add that together. So the mode is going to be 9.07, and approximately my mode is going to be 9. So that will be the height of the student. If the height of the student is in meter or any unit the height of the student is, so we're going to have the same thing here. So this is what I just have. Okay, now looking at this now, you are going to see that this value 9 must fall within this range of 6 to 10, just like the same thing we did in the median. If it falls outside it, then there's a mistake somewhere. So this is our frequency, the frequency for the modal class. And our final answer here is 9. Thank you very much, and please don't forget to subscribe to my channel. In our next video, we are going to move straight, because we are done with the measure of central tendency. We are moving straight to measure of dispersion. So when Hello viewers, welcome to Ajadi Math class. Today we shall continue with our episode on statistics for beginners. Before we proceed, kindly subscribe to my YouTube channel. So in our previous videos, we've been able to look at measure of central tendency, and today we shall proceed with measure of dispersion. And the first we are going to define here is the range. From the definition of range is the difference between the highest and the smallest numbers in a given set of numbers. Now, looking at the first example we have here, we have the find the range of this set of numbers. So from the definition of range, we know that range is the same thing as the highest number minus the smallest number. And from this observation, we can see that our highest is 20, while our smallest is what? 3. So this is going to be 20 minus 3, which is 17. So you can see that calculating range is very easy, even for group data. Just look at the observation given to you, the highest value minus the lowest value. That is the value of range. And secondly, we are going to look at the mean deviation. The mean deviation. So we are going to consider two cases for this mean deviation. And the first case is when you don't have the frequency. So here we are going to have summation x minus x bar over n. Take note, this is an absolute value. When you say an absolute value of x, it can assume two values, either the positive, that means the value of x can be positive or negative. So the absolute value only take into consideration the positive value. So that is the purpose of the x, absolute value for the x. Now let's consider a situation whereby we have a new data set we are going to consider the mean deviation for this same data set 3, 4, 8, 9, 16, and 20. So our observation is 3, 4, as we have up there, 8, 9, 16, and 20. So we are to calculate the mean deviation. The first thing for us to do is to calculate the mean. And in our previous video, we've been able to talk about that. Don't forget that the formula for calculating mean, which is x bar, is the same thing as the summation of x over n. That means all this observation must be added together. So we are going to have 3 plus 4 plus 8 plus 9 plus 16 plus 20. Everything over how many observations? 1, 2, 3, 4, 5, 6. We have 6 altogether. So calculating the mean of this, so we have our mean, which is the same thing as x bar, to be equals to 3 plus 4, 7 plus this, we have 15, plus 25, which is 40, plus this, which is 60 over 6. So our S bar is 10 in that regard. So using this same definition formula to be summation x minus S bar over n, so my mean deviation, I can represent that with MD, is going to be summation of my x minus S bar. That is the positive value, okay, of my x minus S bar. So my x now is 3 minus 10, okay, the positive value of it. The next observation, which is 4 minus 10, plus the next observation, which is 8 minus 10, plus the next observation, which is 9 minus 10, plus the next observation, 16 minus 10, and the last one, which is 20 minus 10. So we are taking the absolute value of the observation. This is going to be over n. How many observations do we have in total? Which is 6. So calculating this now, using the value given to us there, 3 minus 10 is going to be negative 7. Taking the absolute value of that is going to be positive 7. 4 minus 10, you are going to have 6 plus 2. Don't forget, you are taking only the positive value because of the presence of the absolute value, plus 1 plus 6 plus 10, all over 6. And this is going to give us 7 plus this is 13, 15, 16, 22, 32. So here we are going to have 32 over 6. And that should give us 5.3 something. So that should be our what? The mean deviation. And what's the purpose of mean deviation? This is to see how our observation is far from the average. That is the purpose of mean deviation. Hello viewers, welcome to Ajadi Math class. Today we shall continue with our series on statistics for beginners. So today we are going to work on the variance and standard deviation for the ungrouped data. So in our previous video, we've been able to work on the mean deviation for the ungrouped data. So today we shall continue with the variance and the standard deviation. Like I told you, if we're talking about the variance and the standard deviation, this is just looking at the square difference of members from the mean of the data, the deviation from the mean of the data. So today, I'm going to give you the formula for the variance. So the first formula, if it is the population variance, we can use sigma square. Okay, we use this to represent what a variance is. So it's going to be summation x minus x bar, almost the same thing with the mean deviation we did in the last class, squared over n. So the n is the number of what? Observation. Okay, and in this case, alternatively, you can use another method for this, but for the sample variance in which we are going to work on today, we can have s squared to be equals to summation x minus x bar all squared all over n minus 1. So the only difference between these two is that here our n decreases by 1. So that's what we are going to work on today. So for this, we can have this in this form, or alternatively, it can be written as summation x squared over n minus x bar or square. Don't forget our s bar is the mean. So we are going to use these two formulas to solve our example given here. So here we are told that given the following data set 35787, find the variance and also the standard deviation. Yeah, before I proceed, don't forget also that when we talk about the word standard deviation, our standard deviation, I'm going to use STD to represent that, is the same thing as the square root of variance. So whatsoever you get for your variance, just find the square root. So that is equivalent to our standard deviation. Now for us to do this now, the first thing we are going to do, since we are calculating the variance, so our variance is going to be, let me use s squared, yeah, it's going to be, let's use the first formula, x minus x bar all squared over n minus 1. So we need to calculate our s bar first. So calculating our s bar, which is the mean, in our previous video we've shown how to calculate our mean. So that means addition of everything over the number of observation, and that's going to be 3 plus 5 plus 7 plus 8 plus 7. So we're dividing everything by number of observation, which is 5. So this is going to give us 30 over 5. And our mean is going to be 6. So now making use of the formula here, which is summation of x minus s bar. So our variance will now be equals to our x, that means each of the observation minus the mean. So here we are going to have the first observation, which is 3 minus 6 all squared, plus the next observation, which is 5 minus 6 all squared, plus the third observation 7 minus 6 all squared, plus the fourth one 8 minus 6 all squared, plus the last one, which is 7 minus 6 all squared. Okay, we are dividing everything by our n, which is what? Which is 5. So let's use of the population variance. So I'm going back to this. So that means instead of using n minus 1, I'm going to use this in this case, because here we assume that we are working with population, not the sample in this case, because the question does not indicate whether it is sample. So we regard our information given as the population, So solving this now, here we are going to have 3 minus 6 all squared is going to give me 9 plus 1 plus 1 plus 4 plus 1 all over 5. And this is going to give me 16 over 5, which is equivalent to 3.2. Mind you, don't forget that from here, our standard deviation, that's for our variance, right? So here, calculating our standard deviation is the same thing as saying the square root of our variance. And don't forget our variance here is 3.2. So this is the same thing as saying square root of 3.2. So our standard deviation in this case is going to be 1.79. So this is for the first method. This is for the first method. Using the second method, which has been given to us here to calculate. So we are going to make use of this second formula to calculate our variance. So here we have our variance to be equals to summation x squared over n minus x bar squared. So we want to check if we are going to get the same answer for this. So here we need to know our summation x squared first, and since the summation x squared equals, that means each of the observation square, each of the observation, that is 3, 5, 7, 8, 7, we are squaring each of it, is going to be 3 squared plus 5 squared plus 7 squared plus 8 squared plus 7 squared. So this is summation of our x squared, and that is going to give me 196. Okay, and don't forget our s bar square. So in this case now, our variance, my variance here is going to be summation x squared, which is 196 over 5, which is the number of observation, minus s bar all square, and my x bar in this case from here, my s bar is 6, so minus 6 squared. So this is going to be 196 over 5 minus 36. So solving this further, I'm going to get 3.2. So calculating the standard deviation also is still going to be square root of 3.2, which is going to be what? 1.79. So this is for the standard deviation and also for the variance of what? Of ungroup data. Before I leave, I have to tell you this. This can be extended to when you have frequency of number. So that is, our variance, when frequency is involved, can be equals to summation f, okay, into bracket x minus x bar all squared all over summation f. So that's the only difference. Instead of using n here, we are going to use f and f here too. So those are the two formula that we have in this case. Okay, so you can use this to solve this as a classwork and put the answer in the comment section, such that when you have f and we have f, we have 0, 1, 2,